Now I'm going to do what I said I didn't want to do. If here's our final position, here's our initial position, then I'm going to superimpose a delta S vector here. And now our F net vector and our delta S vector combine to give us the work. When we do the dot product of F net with delta S, I don't have a lot of room here, but I'm going to erase my indication of the X and Y directions and draw kind of a facsimile of this thing. I'm going to put our two vectors like this. Here's our delta S. And here's our F net. Now when we do the dot product, we do F net delta S, magnitude of F net, magnitude of delta S times the cosine of theta. Now that's not how we calculated it. We used the other formula for the dot product. Let's look at what all this means. We take our delta S here and we project it onto the direction of F net, giving us a projection vector that I'll call delta S parallel. Now there's some angle here. This is our angle theta. So that in the first place the dot product is equal to the magnitude of this vector times the magnitude of this vector times the cosine of this angle. But of course, the delta S parallel has a magnitude that's equal to the magnitude of this vector times the cosine of theta. So that F net delta S parallel equals F net delta S cosine theta. And that equals, of course, F net vector dotted with the delta S vector. Also, this delta S parallel vector is the projection of the delta S vector in the vertical direction. And the component of the delta S in the vertical direction is just your delta Y. So this equals F net delta Y. Here's your F net, whoops, here's your F net, and here's your delta Y, this projection. So we see that the work done by the gravitational force between any two positions is just equal to the product of the gravitational force and the Y component of delta S. Of course, you got to be careful about the signs. If the Y component of your delta S is downward, well then, since your gravitational force is downward, the two forces will be in the same direction. They'll give you a positive product. So that if something goes lower, gravity does positive work on it. If it goes higher, then the delta S is this way, or the delta S goes this way, the F goes this way. They have opposite signs and the work is negative. Gravity does negative work on something as it rises. Okay, well, work out all these connections. Make sure you understand the ideas that are inherent in this problem.